All right, today we are dealing with three words that you should be pretty familiar with called mean, median, and mode. And something you may not know is that those are called measures of central tendency. So measures of central tendency, I'm going to define for you here as values that represent a typical or central entry of the data. And then I gave you some examples such as mu and x bar. So we're going to kind of fill in this anchor chart together as we go through so that we all have the same information. And then we'll use this information to apply to certain problems. So again, measures of central tendency. I got to set my pen up. I think I was doing something quite different before. Okay, so again, that's going to be values that represent a typical or central entry of the data. Values that represent a typical or central entry of the data. So a couple things here before we get started is that when we're working with means, medians, and modes, but generally means you want to round to one more decimal place than the data. So I am going to kind of just mark this, find some space over here. And this is kind of like a little fun fact for us. Again, round to one more decimal place than the given data is rounded to. So if it's integers, you're going to round to one decimal place. If it's numbers like 1.2 and 2.3, you're going to round to then two decimal places. And that's going to be kind of the rule that we live by here. So mean, this is the first word. That is our main, and it is our most prominent measure of central tendency. When you see mean, I want you to think of adding, because the mean is the one where we need to add them all together. And so our definition for that is featured over here. So add all of the data together and divide by the number of entries. So we need a data set. So let me write you out a data set. Let's use the numbers 274, 235, 223, 268. Notice these aren't in order. 290, 285, and we'll do 235. So this one is the only one where you don't need to put them in order. And the reason for that is because we're just adding them up and like finding the average. And so having them in order won't do you any good. But for your median and your mode, you might find it nice to have them in order. So that's going to be up to your discrepancy if you do that before you find the mean or not. But to follow our directions here, we're going to add these all together. I'm going to put little plus signs in between each entry. We're going to add them all together, and then we are going to divide them. And it says divide them by the number of entries. So you just do a quick count, 1, 2, 3, 4, 5, 6, 7. And so we are dividing by 7. So our mean here, and we can just do that right in our calculator, our mean comes out to 258.5. Oh, sorry, just kidding, 0.6. 258.6, and notice I have that one extra decimal point here because we were given integers, so we want to go one decimal place in front of that. So again, this should be something you're familiar with, and this is finding the mean. So this is saying this is really the average score, and we use that all the time. I use that with test scores all the time, and it's really helpful. When it comes to statistics, we have two different kinds of means. We have our population mean, which we use mu. Mu is how we pronounce it, but it's this like Greek letter M here. So mu is equal to the sum, that's a summation symbol, of your x values over n, and that's a capital N, and that capital N stands for the number of items in your population. But if we're only dealing with a sample, we're going to use what we call x bar, because it's literally an x with a bar on top. And that's still the sum of our x values. But then we're going to divide that by a lowercase n, where n is the number in your sample. So the difference here would be if these were if these were 7 Park Math scores from all my students, instead of saying mean is 258, I would say that the mean x bar is 258.6. But if I only had 7 problem stats students and that was everyone's score, then I would write out my mean like this. So depending on the situation, you'll use x bar or you'll use mu. And that's just the small discrepancy there. Okay, the next measure of central tendency that we know and love is our median. And when you see median, I want you to think middle. So median is middle. So this is when you put the data in order. So you can see I took that same data set and I just wrote it in order this time. And then you want to find the middle entry. So sometimes when I look, I say, okay, I'm going to cross 2 off from the left, 2 off from the right, 1 left, 1 right, and I get 268 right in the middle. So my median is 268. If it's even, however, let's look at this next one. Let's cross 2 off on the left, 2 off on the right, 1, 1. I would have 2 numbers in the middle. So if that happens, you find the middle, the average of the middle. So you're finding the mean of those. So you would do 4 plus 6 divided by 2. And I mean, this one, it was kind of obvious that it was 5, but I did want to model that for you. So in this one, your median would be 5. So if they're odd, you're always going to have a single value in the center. So your median will be one of your values. If it's even, you're going to find the average of the 2 numbers in the middle. Okay. And then mode, if we're thinking median is middle, mode, we're going to think most. Which data value appears the most? And that's going to be so, and you could have one value that occurs the most. You could have none. Or you could have more than one. And if something has 2 modes, it's considered, and this is just a word that you see in math, so I did want to bring this one up to your attention. It would be called bimodal. If it has 2 modes, it's bimodal. So let's run through this data set. So we want to look for the most. So 235 I'm seeing appears twice, and none of the other ones do. So for this one, our mode would be 235. Now, I know that I said that it could have one, more than one, or none. If this other 235 didn't exist, just in this hypothetical here, we're not going to say that this data set has 6 modes. Because if a mode is just one, then that's not really important to us. So I definitely wouldn't say that that's a mode. I would just say there is no mode. But let me unerase that. If I had 235 in there, but I also had another 223 entry, then it would be bimodal, and we would have 2 modes that way. And then if there was another 268, then we could have 3 modes or something like that. So that's how we would get those values. Then there's another word that you may see associated with this word is frequency. Since we just did our frequency charts, I did want to remind you about frequency. All right, and then there was just one more thing while we have here some space on our anchor chart. I did want to quickly discuss an outlier. So let's go ahead and come up with a definition for that. So an outlier is a data entry or multiple entries that is removed from the other entries in the data set. So some are valid and some should be removed. And basically what we're going to be doing is looking for gaps in our text. So let's see if I can get that all down here. So this is a data entry or entries that is removed from the other entries, far apart from or very different than in the data set. Now, some are valid, meaning we need to keep them in the data set, but others should be removed. And then to find them, you're going to look for gaps to find them. I will come up with, as we add layers to this year, we will come up with more specific ways to find an outlier. There is an actual specific way to look for that. But for now, when we talk about outliers in our graphs, we're just going to look for a point or a couple points that really do not fit with the rest of the data. All right, so we're going to take this and we are going to then go over some questions and some practice problems. So those are your measures of central tendency, mainly mu and x bar for mean, but our median, mode, and the idea of an outlier are very important as well.